Hello everyone. In this video, I'm going to discuss about linked list creation, insertion, deletion and all other operations. So before going to watch this video, so in previous video, I explained the basics, how to create a linked list, how to create the node and all. So first you watch that video, then only you can understand this one. Okay, first we'll see how to create a linked list. Linked list means it is a collection of nodes. Node means data and address part. In data part, we can store numbers or characters or complete one student or one person details also we can store, and address of the next node. So I'm going to explain the simple program. So I'm going to store only roll number of student. So roll number of student, then address of the next node. For example, addresses are 500, 600, then 800. Address of next node is 600. And roll number is 20 and address of the next node is 800. Roll number is 21, address of next node. There is no next node, so we have to store null. So this is one simple example of linked list. Now we'll see how to create all these nodes. So we have to store these two members under a single name. So these two are not same type of elements, heterogeneous elements. We have to declare one structure, and using malloc function, we can allocate the memory. So in last video, I explained clearly. So using malloc function, allocate memory for node. So new node is a structure variable. Okay, again I am going to write the structure struct node. So in this node, I'm going to store one roll number and address. Roll number is integer and address means pointer variable we have to declare, and in pointer variable we are storing the address of the next node. So node is the type of structure. So pointer is also a type of structure. Struct node next. This is the structure. And to access structure members directly, I cannot access roll number and next. We have to declare structure variables. So I'm going to declare some NN and first is also one variable, and initially first equals to null, and another variable it is temp. So these three are structure variables. So after closing brace, you can declare structure variables, or another method is struct node pointer variable name nn comma remaining variables also you can add. These are the two methods, or so you can use any one method. Okay, now just allocate memory for new node. Nn equals to struct node asterisk malloc size of struct node. So size of the structure is 8 bytes. So it allocate memory for 8 bytes. First 4 bytes is the roll number, second 4 bytes for next. So how to access the first member new node of roll number, and next member is new node of next. Okay, first just assume the addresses. This is NN. NN is 100. How to access this memory new node of roll number? See, new node of roll number. Okay, if new node of roll number is 5, then it will be assigned here. There is no next node. So new node of next equals to null. So like this, we can create one node. Next, if at all you want to create another node, we have to create it. See, if I'm going to create some 50 nodes, for each and every node, it is difficult to assign the names. We can assign, but it is difficult, it is meaningless. So that is difficult to assign name to each and every node. So that is the reason what I am doing. Only for first node only we have to assign the name. With the help of that name, you can traverse entire linked list and you can access any element with the help of first name. So this new node I am going to assign to first. Simple concept is, I'll tell you simple example. You just entered into your class. When you enter into your class is empty, no one came to class. What you will think in your mind? No one is came, I am only the first person. Here also same thing. Initially, what is first? Null. It means that linked list is initially empty. Just now I created one node. If a first equals to null, it means no nodes present in your linked list. So this new node is assigned to first. Always you cannot assign. If first equals to null, then only new node is assigned to first. Now what is first? 100. Now it is not null. Now first is 100. It means this is the first node in our single linked list. Okay. Now again I am going to create another node. So again execute same statement. Every time you cannot write different statement for each and every node. So again we'll repeat same statement. Then for new node it allocate the memory. So now new node is 200, not 100. This node name is first, this node name is new node. Okay. And read one number that will be assigned to new node of roll number and new node of next is null. Okay. Like this. Just created second node also. Now you have to combine these two nodes. Have to combine in place of null. I have to store 200. What is 200? New node. So have to access this place, this memory first of next. Okay. First of next. In first of next, what you have to store? NM. Okay. Fine. 200 I'm going to assign. Fine. Like this you can add. Again, I want to create another node. Now, it becomes new node. This is not new node. Okay. Read roll number. New node of next is null. This is third node in our linked list. After second node, I have to add this third node. But second node, I did not assign any name. So, where I have to assign this new node? So, little bit it is difficult. So, first time when we create one new node, read roll number, new node of roll number, new node of next is null. What you have to check? If first is null, yes, initially the first is null. So new node is assigned to first. And same way assigned to one more variable. Any variable I have taken temp. Okay. I'll tell you why I assigned it to temp. Because every time after first you cannot assign the new node. Okay. That is the reason new node is assigned to temp also. Next, again, I'm going to create another node. So this is new node. Now, this is not new node. It override the previous one. See, simple example, x equals to 10. It means 10 will be assigned to x. Okay. Now, x equals to 20. Now, 20 will be assigned to x. It override the previous value. Here also same thing. Again, if you execute same statement, again it allocate the memory for nn. So, it override the previous. Now, it becomes new node. Read one number that will be assigned to new node of roll number. New node of next is null. So, where we have to add this new node means after temp. So, temp of next equals to 200. 200 means new node. Temp of next equals to new node. New node is 200. Temp of next means this memory. So, in place of null, it will assign 200. Okay. Next. Now, new node is assigned to temp. Now, this is only first node. This is new node and temp node. So, if at all, if you want to create another node, create one new node. Now, new node is 350, not 200. Read one number, assign to new node of roll number. New node of next is null. Okay. Now, we have to add this new node to our linked list. Where we have to add? After temp, easily you can add temp of next equals to new node. See, temp of next equal to new node. Temp of next equals to new node. Now, what is new node? 350. Now, in place of null, it will assign 350. Now, new node is assigned to temp. So, every time new node is assigned to temp. Then, after temp, easily you can add new node. So, we'll take one more example. Again, I'm going to create one new node. Read one number, new node of roll number, new node of next is null. Now, new node is 500, not 350. It override the previous one. So, where we have to add this new node after temp. See, temp of next equals to new node means 500. Like this, n number of nodes you can add to your linked list. This is not insertion. Creation means n number of nodes you can add into your linked list. Means in sequential order, one by one you are adding. This is creation. We'll see the code also. First, we have to declare one structure, struct node and members. So what are the members? We are storing only roll number and pointer variable. So roll number is integer and pointer variable. Pointer variable, it is structure type. Struct node, pointer variable is next. Next, structure variables. With the help of structure variables only, you can access the members. So new node is one variable. First is one variable. First, initially it is null. And one more, it is temp. So all these are structure variables. So now I'm going to write code for create function. Okay. Create means first you have to allocate memory for new node. Have to allocate memory for new node. Struct node asterisk malloc using malloc function. Malloc size of struct node. All these things already I explained in previous video. If you are not understanding, please go and watch my previous video. Okay, first create one new node and read one roll number. Printf enter roll number. That will be assigned to any one variable. I'm going to assign to one x, %ld ampersand x. Okay. Now this x is assigned to new node of roll number equals to x. First, what we are doing? We are creating one new node and then read one number that will be assigned to new node of roll number. This is new node of roll number. If at all x value is 10, 10 will be assigned to here. Okay, next. New node of next equals to null because there is no next node. So new node of next equals to null. Just now I created one new node, read one number that will be assigned to new node of roll number. New node of next is null. So same thing I am going to draw here. This is new node. It allocates memory. First byte address will be assigned to new node. Read one number that will be assigned to new node of roll number. New node of next is null. So after creating new node, so if at all your list is empty, the new node is assigned to first. How can you check the list is empty? Initially, what is first value? Null. If first equals to null, it means that whatever we have created, that one becomes the first node. So you have to check one condition. If first equals to null. If first equals to null, initially anyway first is null. Just now you have created one node, that one becomes the first node. So new node is assigned to first. First equals to new node and new node is assigned to temp also because every time after temp easily you can add new node. That is the reason new node is assigned to temp. And anyway this one becomes the first node, so new node is assigned to first also. So initially first is null, so new node is assigned to first and new node is assigned to temp. Fine. Next time again if at all you want to create another node, you have to go back and create new node, read number and new node of next is null. So again I am going to create one new node and new node is 200 not 100. Read one number that will be assigned to new node of roll number. New node of next is null. After creating once again we are checking the condition. If first equals to null, no. What is first? 100. So it is not null. Then where I have to add this new node? After temp. So in else part what you have to write? After temp we have to add new node. Temp of next. Temp of next equals to new node. Temp of next, in place of null it will assign 200. See, temp of next is 200. So in place of null it will assign the 200. Next, now it becomes temp. So after temp easily you can add new node. Now new node is assigned to temp. So temp equals to new node. Now new node will be assigned to temp. Now this is first node, this is the temp node, and I'm going to close this else part. I'm just incrementing count value by 1 just to count number of nodes in your linked list. Initially count value is 0. After creating each and every node, you have to increment count value by 1. So either it will execute if part or else part, and it increment count value by 1. After creating one node, if at all you want to create another node, you have to go back. That is the reason just asking one question, that is printf, would you like to create another node? If at all you want to create another node, simply enter 1, otherwise enter 0. So both are integers. So I'm going to assign to one integer variable, that is ch. If ch is 1, what I have to do? I have to go back and I have to execute all these statements. So I have to write all these statements in one loop. So I'm going to write in do while ch is equals to 1. If ch equals to 1, again it will go back and it will execute. Okay, see, and again I'm going to close the create function also and declare ch. First we are creating one new node and roll number we are assigning, new node of next is null. Okay, it will check the condition. First equals to null. Yes, initially first is null. So new node is assigned to first and new node is assigned to temp. Okay, it won't execute the else part. Simply it increment count value by 1. Now count becomes 1 because one node we have created. It will ask you one question. Would you like to create another node? If at all you want to create, select 1. If we select 1, if ch is 1, then again it will go back and it will execute all the statements. Again it will create one node. So create one node. Now it becomes new node. Now new node is 200. Read one number, assign, new node of next is null. See, again it will check the condition. First equals to null. No, first is 100. Then it comes to else part. Temp of next, it will add new node. Temp of next equals to new node. Means in place of null, it will assign 200. Now new node is assigned to temp. Now temp is 200. This node name is first. This node name is new node at temp. Okay. And it increment count value by 1. Now count becomes 2 because 2 nodes in your list. And once again it will ask you question. Would you like to create another node? Yes. Again I want to create. I have to select 1. If it is 1, again it will go back and again it creates one new node. For example, if new node is 350, then read one number, assign, new node of next is null. So once again it will check the condition. Now first equals to null. No, first is 100, not null. So new node, it will execute the else part. Temp of next equals to new node. In temp of next it will add new node, that is 350 will be assigned here. Now new node is assigned to temp. Okay, now new node is assigned to temp. So like this, after temp, again you can add next node. Like this, n number of nodes you can n number of nodes you can add to your linked list. This is create function. Next we'll see insert function. Now we'll see how to insert node into single linked list. This is one example of single linked list. In single linked list, first node only having one name. So that is first. You can assign any name, but I have assigned it to first. It means this is the first node in our linked list. Each and every node we cannot assign the name. Only the first node name is first. Okay. Now we can insert the node. Insert means in any position you can insert the node. You can insert before first node, you can insert second position, third position, or after last also, after last node also you can insert the node. So now how many number of nodes are there? 4. So count value is 4. That is every time after creating we have incremented count. Now this time the count value is 4. For example, I want to insert in first position. In first position one node is there, but I want to insert in first position. It means before first I have to create. Okay, you have to read the position, in which position you want to add the new node. For example, if position is 1, so whatever the position, first of all we have to create the node. See, I am going to create new node So if position is 1 means before first it will assign the node. If position is 4 means after. Somewhere it allocate the memory, but using addresses we are pointing that one. Okay. Now just create one new node. Read one number that will be assigned to new node of roll number. New node of next is null. If at all position is 1, where we have to insert before first node, we have to add new node. How to add new node? Now new node of next becomes first. Okay, new node of next equals to first. First means 100. So in place of null, it will assign what? It will assign 100. New node of next is 100. Like this. Before first we can add new node. If at all if you add new node before first, now which one becomes first node? New node becomes first node. Now it becomes second node. So now new node is assigned to first. Now first is 600, not 100. Okay, like this easily we can add one new node at position 1. Simply create one new node before first. So new node of next. See, new node of next we have assigned first. After assigning, the new node becomes first. So first equals to new node. Okay. Anyway, we have inserted one new node. So increment count value by 1. Position is not 1. If position is greater than 1. Okay. Now count value is 5. You can insert in first position, second, third or fourth or fifth or 6th. After 5th also you can create one, you can insert the node 1 to 6 positions. In 7th position means there is no 6th node, then how can we insert in 7th position? We cannot. So if at all position is greater than 1 and position is less than or equals to count plus 1. Okay, if it becomes true, then we'll see how to insert. So first of all, I am going to create one new node. Now this is one new node of roll number, assign one value, new node of next is null. If at all position is 4, in 4th position I want to insert the new node. I want to insert new node in 4th position. It means after 3rd node we have to insert this new node. How to insert? 3rd node doesn't have any name. Simple logic is, if at all we can assign any name to 3rd node, after 3rd node easily we can assign this, we can insert this new node. So first of all, the first is assigned to any one variable. So I am going to assign first to temp. Now temp is 100. Temp move from first node to 3rd node, because after 3rd node we are inserting the node. How to move? See, first temp equals to temp of next. What is temp of next? This is temp of next, right? Temp of roll number is 11. Temp of next is 200. Temp of next is assigned to temp. See, temp equals to temp of next. So what is temp of next? 200. 200 will be assigned to temp. Now temp is not 100, it is 200. Once again repeat this statement, temp equals to temp of next. Now temp of next is 300. So now it becomes temp like this. From first node to 3rd node, we can move temp from first node to 3rd node. So this statement we have to write in any one loop. So repeatedly it will execute. If at all you want to insert in 10th position, just you assume there are 20 nodes in your linked list. In 10th position, I want to insert the new node. So after 9th, it means temp move from first node to 9th node. So after temp easily you can insert new node. Come back to our example. So in 4th position we are inserting the new node. Now the 3rd node name is temp. So after temp I have to insert this new node. So what I have to change? Temp of next I have to change. New node of next also I have to change. So first we'll change new node of next. After that we'll change temp of next. So once first, if at all, if you change this address, you cannot change this one. So first of all, you have to change new node of next. It is very simple. After temp, you are adding the new node. Means in middle these two nodes, we are adding new node. See, whatever temp of next, that becomes the next of the new node. That is only the logic here. See, temp of next node is 400. Once you insert 600 in middle, 400 becomes the next of 600, means next of new node. See, temp of next becomes new node of next. So new node of next, what we have to store here? 400. Where is 400? Temp of next. So temp of next is assigned to new node of next. It is very simple. Temp of next node, it becomes the next of new node. So temp of next is assigned to new node of next. So in new node of next, temp of next is 400. Just assign 400. Okay. Next, we have to change temp of next also. Now which one becomes temp of next node? New node. Temp of next equals to new node. What is new node? 600. 600 will be assigned here. It will change this arrow. See, in temp of next stored 600, 600 of next is 400. So in middle 300 and 400 I have inserted one node. Okay. Now the count value is 5. Okay. Now the count value is 5. Now I want to insert element in 6th position. Okay. So again create one new node. So for example it is 700. Read one number, assign new node of next is null. Okay. Now if at all you want to insert node at 6th position, you have to assign one name to 5th. So this is temporary purpose we have used. Only the first node name is first. Okay. Now first is assigned to temp. Now temp move from first node to 5th node. How to move? Temp equals to temp of next, temp equals to temp of next, temp equals to temp of next, temp equals to temp of next. Like this, just repeat the statement. Temp, like this you have to move one by one node. Now it becomes temp. Now 5th node is assigned to temp. Now after 5th node I am inserting one new node. Now temp of next I have to add this new node. Okay. Simply temp of next equals to new node. So anyway, so you can repeat same thing also. So new node of next equals to temp of next. Anyway already it is done. So only you have to change one thing, that is temp of next equals to new node 700. So temp of next we have to add, we are adding new node. So like this, after last node you can insert, middle also you can insert, and before first node also you can insert. We'll see the program. Insert function. So insert means first of all we have to create one new node, then read position. In that position we have to insert. So first of all I am going to create one new node. Have to create new node, struct node asterisk. Using malloc function we have to create malloc size of struct node. So it allocate memory for new node. Read one roll number. So printf enter roll number. That will be assigned to any one variable. I am going to assign to x. Okay. Now new node of roll number equals to x. New node of next equals to null. Like this, create one new node. Next we have to read the position, in which position you want to insert this one. So printf enter position. So in which position you want to insert, read that position. Scanf %pos is one variable. In that variable I am going to assign. So if at all it is 1, in first position you have to insert. Okay. See, if position equals to 1. If position is 1 means before first node we have to insert. See, take. So I am going to take this example. So just now we have created one new node. Like this is new node, read number, assign, new node of next is null. And before first, how to add? In new node of next we have to assign the first. New node of next equals to first, and new node is assigned to first. These two statements we have to write. So before first you are adding the new node. So new node of next equals to first. So with the help of diagram easily you can write the code. When you are writing the code, definitely you must draw the diagram. So first time when you are going to write, once you practice, you can imagine the diagram and you can write. So new node of next equals to first, then new node becomes the first node. So first equals to new node and increment count value by 1. So like this, if position is 1 before first node, you can add new node. So new node of next node is the first. Now first new node becomes the first node. Else, if position is greater than 1 and position is less than or equals to count plus 1, means middle or last, if at all you want to insert in middle or if at all insert in after the last node, then have to insert, already we have inserted, right? I'll show you that. You have to insert, if at all, first thing is, if at all you want to insert in 5th position, temp move from first to 4th position. See, if at all you want to insert in 4th position, temp move from first node to 3rd node. After 3rd node, you have to insert. So have to insert, this is the new node. Have to insert the temp of next becomes new node of next. See, temp of next 350 becomes new node of next. Temp of next is new node. So like this, we have to add. First is assigned to temp. Temp equals to first. Now move temp from first node to position minus 1. So for loop, using for loop, I am moving I equals to 1, I less than position minus 1, I plus plus. We have to move from 1 to position minus 1. So have to move temp equals to temp of next. Every time next node becomes temp. Next node becomes temp. Like this you can move. After moving, so after temp we have to add the new node. So temp of next becomes new node of next. So new node of next equals to temp of next. It's a very simple. The temp of next node becomes new node of next. Now what is temp of next? New node. Temp of next equals to new node. Increment count value by 1. That's it. So this is insert function. These two are local variables, x and position. First of all, you have to create one new node, assign roll number, and initially new node of next is null. Next, read one position. If at all position is 1, before first node, you have to add the new node. Once you add new node, the new node becomes the first node. Anyway, after creating the node, we have to increment count value by 1. If at all position is not equals to 1, see, if at all it is greater than 1 and less than or equal to count plus 1, then first temp move from first is assigned to temp. So now temp is at first node. Now temp move from first node to position minus 1. Okay. Afterwards, temp of next becomes new node of next. Temp of next equals to new node becomes temp of next. So just you have to practice the diagram. Once you understand the diagram easily, you can write. Else, invalid position. If nodes are 5, if at all the position is 10, how can you insert? That is not possible. Just print one message, invalid position, and close this insert function. This is insert function. Next we will see delete function. Next we'll see how to delete a node from linked list. So insert means we have to create the node and insert. Delete means easily just we have to remove node from your single linked list. So this is the first example. This is one linked list. So you can delete first node, second or third or last node also you can remove. Middle nodes you can remove. First node also you can remove. So first we'll see how to remove the first node. So I want to remove this first node. Anyway, the first node is having one name, that is first. This node I want to remove. So I can remove. Free first means it will remove. But the next, once you remove this one, the next one becomes the first node. So first the next node is assigned to first, then you can remove this one. So that is the reason first is assigned to one PTR. PTR is also structure variables. See, these two are variables, these two are the members. With the help of variable you can access the member. Okay. Now, first is assigned to PTR. Now, what is first? 100. What is PTR? 100. This node name is first PTR. Two names I have assigned. Okay, if at all you want to remove this node, after removing the next node becomes the first. So now 200 is assigned to first. So where is 200? First of next or PTR of next? Both are same. So first of next is assigned to first. First equals to first of next. What is first of next to 200? 200 is assigned to first. Now first is 200, not 100. This is PTR, this is first. Now happily you can remove this node. How to remove this node? Free PTR. Free PTR means it will remove this one. After removing, decrement count value by 1. Okay, we'll take one more example. So this is another single linked list. I want to remove fourth node. Okay, if at all you want to remove fourth node, temp move from first node to third node. Same what we did in insert function. If at all you want to remove fourth node, temp move from first node to third node. First is assigned to temp. Temp move from first to temp equals to temp of next, temp equals to temp of next. Now third node name is temp. Temp of next node I want to remove. So whatever you are removing, that is assigned to PTR. Temp of next is assigned to PTR. Now I have to remove PTR node. If at all, if you remove this PTR, the next node becomes temp of next. 600 becomes temp of next. In place of 400, I have to store 600 because we are removing this one. In place of 400. In place of 400 means temp of next I have to change. See, temp of next I have to change. What I have to change in temp of next? I have to store 600. Where is 600? PTR of next. See, temp of next equals to PTR of next. See, once you remove this one, the next node becomes temp of next. Very simple logic. You are removing this one. So, PTR of next node becomes temp of next. See, PTR of next is assigned to temp of next. Okay. Now, 600 will be assigned here. It points to 600. Now, you can remove PTR. Free PTR means it will remove this one. Like this, you can remove the middle node. Now, take another example. In this linked list, 4 nodes are there. I want to remove fourth node. Fourth node means last node I want to remove. If at all you want to remove the last node, again same. Temp move from first node to third node. Same logic. For middle node and last node, same logic we can write. So, temp move from first node to count minus position minus 1. Position is 4. So, you have to move from 1 to 3. Now, which node you are removing? Temp of next node. That is assigned to PTR. So, once you remove the PTR, so PTR of next becomes, see, the statement is PTR of next node becomes temp of next. But there is no next node. PTR of next is null. So, once you remove the PTR of next you can assign to temp of next. What is PTR of next? Null. So, temp of next is null because there is no next node. So, now you can remove this PTR. Now, temp of next is null. It means that this is the last node in our list. So, these are the 3 different situations. You can remove first node, you can remove middle node, or you can remove the last node. The same code you can apply for middle node and last node. Function is delete. Void delete 1 I am taking because delete is a predefined word. So, delete 1. This is the delete function. So, first you have to read the position. Which node you want to delete, that you have to read. Printf. So, simply I am writing enter position means which node you have to remove. Complete statement you can write scanf %id ampersand position. So, if at all position equals to 1, it means the first node we have to delete. Just you check it once. Just now we have discussed how to remove the first node. The first is assigned to PTR. Then first to move to the next node. Then you can remove the PTR. Okay. Now first is assigned to PTR. So PTR I did not declare. So you have to declare the PTR. PTR is also a variable. Struct node asterisk PTR and position int position comma I position comma I. These two are normal integers. So first is assigned to PTR. The first node is assigned to PTR. So if at all you want to remove the PTR, first move to the second node becomes the first. See, so if at all you want to remove this node, first of next is assigned to first, then you can remove the PTR. Okay. Now I am going to change the first node. First equals to first of next. Now you can remove this PTR. Free PTR and decrement count value by 1. Like this we can remove the first node. Else if position is greater than 1 and position is less than or equals to count. See, 10 nodes are there, then count value is 10. You can remove 10th node, but you cannot remove after 10th node, 11th node, 12th node. There is no 11 and 12, so you cannot remove. So position is greater than 1 and less than or equals to count. So in that case, what you have to do? First temp move from first node to position minus 1. Okay, have to move temp equals to first. First is assigned to temp and move. For I equals to 1, I less than, position minus 1, I plus plus, temp equals to temp of next. Like this you have to move temp from first node to position minus 1. See how we just deleted the fourth node. Temp move from first node to third node. So next whatever you are removing, that node is assigned to PTR. Now temp of next node is assigned to PTR. PTR equals to temp of next. So now temp of next is assigned to PTR. Now we have to remove this PTR. Once you remove the PTR, PTR of next node becomes temp of next. See, temp of next equal to PTR of next. Temp of next equals to PTR of next. Temp of PTR of next will be assigned to temp of next. Now we can remove this PTR. Free PTR count minus minus. Else invalid position. You cannot remove. If 10 nodes are there, so remove 11th node means it is not possible. So else print one message, invalid position. And I am closing this delete function. This is delete function. Next one, it is display function. So display means we have to display all these roll numbers, means data part we have to display 5, 6, 7, 8, 9. So have to display first of roll number means it is 5. So next have to display this 6. So first is assigned to temp. So first what you have to display? Temp of roll number. Then temp move to next node. Again display temp of roll number. So it will display 5, 6. Again temp move to next node. What is temp of roll number? 7. Again move to next node. Temp of roll number is 8. Again move to next node. How to move? Temp equal to temp of next. Now temp of roll number is 9. So how many times you have to move like this? See, now temp equal to temp of next. What is temp of next? It is null. If it is null, you cannot display. So until it is null, you have to display temp of roll number. So I am going to write it here only, void display function. So display. So anyway, if at all you want to check list is empty, then write one condition. If first equals to null means list is empty, you cannot display. Otherwise we can display. I'll show you how to display the elements. So first is assigned to temp. It means temp equals to first. So first is assigned to temp. Okay, you have to repeat the loop repeatedly. What you are doing, displaying the roll number, and temp you are moving to the next node. So these two statements we have to write in one loop. I am going to write while. What condition we have to write? Until it is null. It means the temp is not equal to null. You are displaying the roll number and you are moving temp to next node. So while temp is not equals to null. If not equals to null, what we are doing? Simply we are printing the roll number. %d/t for spaces, tab spaces, and temp of roll number. After displaying temp of roll number, what you are doing? Temp, we are moving to the next node. So temp equals to temp of next. Close this while loop and display function. This is display function. Any doubts you can ask in comment section. Thanks for watching.